So welcome everybody to this latest KS3 GCSE video on 160 Maths, and in this video we'll be continuing with trigonometry with a focus on using trig ratios to find other trig ratios. Now these questions tend to be very popular now on non-calculated papers for both the higher and foundation papers. Now prior knowledge before working through this is that you need to have covered Pythagoras theorem to work out missing sides of right angle triangles. Now, one of the most popular questions I get asked as a teacher after teaching trigonometry from students is, will this ever appear on a non-calculated paper? Now, typically when you're working out the sides and angles of right angle triangles, typically this would appear on the calculated paper for both higher and foundation. However, there is an increase of trigonometry appearing on the non-calculated paper. Now, if it does appear on the non-calculated paper, it usually relates to the exact values of trig, in which often it's a multiple choice question in which you just need to highlight the right answer. However, these types of questions that we're going to go through in this video are appearing a lot more and more on both the higher and foundation paper. So let's have a go at working this out. So the question, example 1, says that given that tan x equals 4/5, find sine x. Now at face value you may be thinking, what on earth is this question on about? I haven't even been given a triangle. I know what tan x is, it's going to be 4/5 is 0.8, but how on earth am I supposed to find out what sine x is without a calculator? Well, the important thing for this is to remember what tan x actually represents. So when we use tan, we know that tan x equals the opposite over the adjacent. So that therefore means that the opposite is going to be 4 and the adjacent is going to be 8. If we imagine that we've got a right angle triangle, which I'm just going to do a little sketch here. So this is going to be x, this is my opposite, this is my hypotenuse, and this is my adjacent. So from this fraction that I've been given, or this value, it says, well, it gives me the impression that opposite is going to be 4, and let's just use that as a different color, and that the adjacent is going to be 5. Now using Pythagoras, I can see that h squared is going to be equal to o squared plus a squared. Now if I just replace the numbers from that, what I'm going to end up with is h squared equals 4 squared plus 5 squared. So h squared is going to equal 16 plus 25. So h squared is going to equal, and that's going to be 41. So therefore h is going to equal the square root of 41. What I can then do is write this as 41. So now I've got the 3 measurements of the dimensions of this right angle triangle. So I know the opposite, the adjacent, and now the hypotenuse. I can then work out what sine x is. Now sine x is equal to opposite over hypotenuse, and in this case the opposite is 4 and the hypotenuse is the square root of 41. Now do I need to know what the answer of that is? No, because the question's asking me to find out what sine x is, and that is exactly what I have found. So this here is my final answer. Now as an extension, if I wanted to work out what cos x was, well, cos x is equal to the adjacent over the hypotenuse. So again, looking at the triangle, I've got that cos x is going to equal the adjacent, which is 5, over the hypotenuse, which I've worked out to be is root 41. Now if a question asked me to work out x's, so for example, if a question asked me to find x, then what I would then need to do is, well, I'd have to use my calculator. And what we have to do is use the calc, or use your calculator rather, and for that it's a pretty pointless question, because all I then have to do is, if tan x equals 4 over 5, then x is going to equal the inverse of tan of 4/5, and then therefore whatever that is, which if I just reach for my calculator, and what I do is just simply put that in, and I get an answer of 38.7 degrees to 1 dp. But again, if it's a non-calculator, then this won't be expected in terms of finding x. What they'll be wanting you to do is either find cos x or sine x. So let's have a look at our second example. So again, this time we've been given that sine x equals 3/8, and we need to find what cos x is, and for b we need to find out what tan x is. So again, what I'm going to do is I'm going to start off by drawing a right angle triangle, and I'm going to label one of the angles x. So from this is going to be the opposite, that's going to be the hypotenuse, and this side here is going to be my adjacent. Now in terms of the information that I've been given, well, to work out what sine x is, well, that's going to be equal to the opposite over hypotenuse. Cos x is equal to the adjacent over hypotenuse, and tan x is equal to opposite over adjacent. So from this and the fraction I've been given, that the 3 represents the opposite and the 8 represents the hypotenuse. So here I'm just going to label what I know, and there we go. So then finding out what a is, what I then need to do is again use Pythagoras. So here from this, what I've got is I've got that a squared is going to equal 8 squared minus 3 squared. Now again, in terms of a squared, again, it's not too bad because a is one of the short sides in Pythagoras, but just be wary of the labeling of your triangle. Try not to get confused in terms of a being any other side. Well, it's always going to be adjacent in terms of this. So what we've got is we've got a squared equals 64 minus 9, which then gives me a squared equals, and that's going to be 55. And so a equals the square root of 55. So what I can now do is label this as root 55. So then in terms of part A, what I can then do is that cos x is equal to the adjacent over hypotenuse, which is equal to root 55 over 8. And that would be my final answer. For B, in terms of tan x, well, I know that tan x is opposite over adjacent, and looking at the diagram, I've got that tan x is going to equal 3 over square root of 55, and there is my final answer. And again, I don't need to simplify any of that. If I can, great. Sometimes it might be a show that question, may have to rationalize the denominator, but again, it's all based on the questions that's been given in the exam, and obviously goes into another topic. Now, one thing I would strongly recommend is that you do include this in your working out, because particularly for part A would probably maybe worth about 3 to 4 marks, whereas part B may only be worth 1 or 2 marks, simply because you would have needed to have done this triangle to work out what the adjacent is in order to work out the answers to for both A and B. So let's have a look at this question here. Now, this question says that if cos x equals 5 over 8, find the value of sin x relating to this particular diagram. Now again, if the diagram wasn't given to me, then what I would do is I would draw a right angle triangle. I know that cos x is equal to adjacent over hypotenuse, so if that's equal to 5 over 8, then the hypotenuse will be equal to 8 if I call this x, and the adjacent will be equal to 5. Now the problem with this is that I've got 8 and I've got 40 in the diagram. So obviously what I've noticed is that this fraction here has been simplified. So if this is supposed to be 40, well, and I've worked it out to be 8, what do I need to multiply 8 to get 40? Well, I need to multiply that by 5. So then to work out what this length here is, if I just highlight it in a colour that you might be able to see, let's do it in blue. So this here, or the adjacent of that first big triangle, then what I need to do is I need to multiply this 5 by 5 as well, which then gives me 25. Now from this, what I then need to work out is what sin x is. So if I then take out this triangle here, and what I've got is, and that's why I've got that this side here equals 25 and this equals 7. Now to work out what sin x is, I need to know what the opposite is, I need to know what the hypotenuse is. Now I know that the hypotenuse is 25, so what I need to do is I need to work out what the opposite is going to equal. Now to do that, what I need to do is I need to do 25 squared minus 7 squared equals O squared. Now working this out, 25 squared minus 7 squared, if I do that on in terms of simply just working that out, I get 576 equals O squared. So O is going to equal the square root of that answer of 576. Now that in itself actually equals 24. But again, what you could either do is leave it as square root of 576, or if you're really good with your square roots, you can leave it as 24. So what I've got is that I've got this equals 24, or I could write it as the square root of 576. So from this, what I'm then going to do is go back to the original question. It's to find the value of sine x. Well then, therefore, that final answer is that sine x is going to equal 24 over 25, or it's going to equal the square root of 576 over 25. And that there is my final answer.